Moving on now to topic 6.8. Here we're dealing with formulas, applications, and then later variations. And some of the key words: direct variation, inverse variation, joint variation, combined variation, models. So here are some of the formulas, and what they're asking us to do here is to solve for various letters within the formula. So here we want to find out what T is, which is right there. Here we want to solve for the letter A. Here we want to solve for the letter D. And here we want to solve for the letter W. So now that we've identified that, we can get rid of those. Okay. Now you recall way back in an earlier chapter, we talked about strategies for solving equations. Well, the first thing we want to solve is to get rid of fractions. So we have a couple of fractions here. Then get rid of parentheses, but we have no parentheses here. So let's get rid of fractions. We're going to do so by multiplying each term when there's a fraction, and these all have fractions, by the lowest common denominator, which happens to be T here. And here our lowest common denominator is DH. And we'll do these first. Now, since we are multiplying each term by T, here the T's cancel out, and we're now left with Tn equals Y, and we want to solve for T. So now we just divide by N. And we end up with T equals Y over N. Now, a shortcut would be when you see something like this, you can just reverse these, which is what we've done. But whether you can pick up on that or not, that'll be maybe down the line, but this is the technique. So here we're going to cancel out the D. Here we cancel out the H. And there we don't cancel anything out. So here we have HA plus DA equals DH. And we want to solve for D. Notice we have D in two terms. So we're going to take this D term over to this side. So we'll have HA equals DH. Now when we transpose that, it changes its sign, and we have that. So we're just taking this positive DH, subtracting a DH from both sides, or just transposing. Now we have a D in two terms. So we get the D out by factoring it out. And now, change colors maybe a little bit. We're going to divide both sides by H minus A. And then here these cancel out. And that's what D is. D is HA over H minus A. In number 7, again, we're going to multiply both sides by the lowest common denominator, which is A plus 5A. So we'll multiply this side by A plus 5A. Get that out of there. A plus 5A. Okay? So here, this disappears. And now what I'm going to do is multiply these two terms by the g. So I get GA plus 5GA equals 3x. Now again, I want to isolate the a term, the a factor here. So I'm going to transpose this to the other side. And here it's critical to watch that this is a lowercase a, this is a capital A, not to get them mixed up. And we want to isolate that a, so we're going to divide by g. And that would be one way. And again, I'm not sure what the book is asking, because I didn't look at that one. But another way to do that, and let me just separate that. Divide this by g, divide this by g. And notice here the g's would cancel out. So a could be a equals all of the top over g, or put the g under each term, and then you could cancel that g out. I'll have to look to see what answer they want here. Let me see here. This is number 7. Yeah, they want it all over G. But that way would be good too. Okay, for number 8. What's your common denominator? Well, U, V, W. U, V, W. U, V, W. U, V, W. Now, we cancel out the U. Cancel out the V. Cancel out the W. So we now have VW plus UW equals UV. And we want to solve for W. Remember, W is in two terms, so we have to factor the W out. V plus U equals UV. V plus U, V plus U. They cancel out, and W equals UV over V plus U. Now, I went a little quickly on some of this, but hopefully you're catching on, and again, a very colorful board there. Okay, as we go on, I picked out a couple of others that would be maybe a challenge, but let's see what we can get here. So we want to solve for PQ there. And here we want to solve for X sub 2. So we're going to multiply both sides. Remember, we can use that proportion that we had in the last section here. So this becomes n squared, multiplying this times that, equals 2m. So we're just, in a sense, cross-multiplying. And they want us to solve for PQ as a unit. So we just divide by n squared. And we get then P plus Q equals 2m over n squared. Oh, that wasn't too bad. And the same thing here. We're going to cross multiply, and we get m x sub 2 minus m x sub 1 equals y sub 2 minus y sub 1. And we're going to transpose this to the other side, and we get m x sub 2 equals y sub 2 minus y sub 1 plus, now, when we transpose that, m x sub 1. And now we just divide everything by m. The m's cancel out, and we get x sub 2 equals that. Now, if you put the m under each term, here the m's could cancel out, but they didn't use that method before, so we'll leave it this way. Okay, now we're going into variation a little bit. And our first one is what we call direct variation. And I'm assuming you had a class on this as well. Here we're just reviewing a little bit. And anytime you have a direct variation, the formula is y equals kx, where k is called the constant of variation. Now you might remember from an earlier chapter where we had y equals mx plus b, where we said m was the slope there. Well, in essence, that's the same formula. K is sort of the slope, but when we talk about variation, we call it the constant of variation. So they give you this. They say y is 55 and x is 5. Find the constant of variation. So you set it up. Y is 55. You keep the k, and you put in the 5 for the x. You divide both sides by 5, and you get k is 11. So your constant of variation is 11. Well, what is your new formula for variation with this constant? And it would be written then, y equals 11x. So they're asking you for a couple of things. You had to find k, and then you put the k to replace it in your direct variation formula. And then the same thing for 14. It was different enough, so I did this one. Again, you're using this direct variation formula. You're going to put the 2/3 where the y is, the 8 where the x is, and you want to solve for k. Well, since this is a fraction, I multiplied both sides by my lowest common denominator, which was 3. Here the 3's cancel out, and I get 2 equals k, and then 8 times 3 is 24. So 24k. I divided both sides by 24. I get k equals 2 over 24, which is 1 over 12. So my equation for direct variation with this information will be y equals 1/12 x. And we'll go on. We're continuing on topic 6.8, and we now moved from what were direct variation to inverse variation. And they will tell you that in the problem what type of variation we're dealing with. And I don't know if I mentioned this before, but anytime they say they are dealing with direct variation, I strongly advise you to write this formula. And then anytime they say it's inverse variation, we'll write the formula y equals k over x. So then they're going to give you two items of data. An item for y is 7 here. K you need, that's your constant of variation, and x will be 9. So 9 times 7 is 63. So k is 63. And your formula of inverse variation here would be y equals k. K now you are replacing with your 63 over x. So in many of these they want two parts. They'll want solve for k and then present it in your equation. All right, this one's a little tricky because when you set it up, it's inverse variation. It'll be 72 equals k, but x is 1/12. So what you're doing is you're multiplying, in a sense, you can kind of cross multiply here. You're doing 1/12 times, well, let's take a step back. We're going to multiply 72 times 1/12. There we go. So actually 12 is going to go into there 6 times. So we find then that k is 6. So our formula of inverse variation here will be y equals, we know that k is now 6 over x. Now in number 17, we're going on to do some applications, that is, word problems. And the first one we're faced with here is Hooke's law. And you might remember this from physics class or 9th grade science class or something, where you have a scale with a hook on it, and in here there's a little device, and as you put weight on this, the weight goes down. Well, Hooke's law says the distance is equal to a constant times the weight or mass. So they say the distance is going to be 50 centimeters and the weight is 6 whatever. And you need to find what k will be. Well, you just divide both sides by 6, and this gives you k is 8 1/3, which I put in a fractional form. And then the second part of the question is, how far would it move if you put a 2, and let me see what kind of weights they're talking about here. kilogram weight on there. So you would multiply 2 times your constant of variation, and that gives you 16 2/3 or 16.6 centimeters. So little word problem. Again, it told you that it was a direct variation. So there is the general formula for direct variation, but here they're using D for Y and M for X. An interesting note today is it's March 31st, and this is what it looks like outside the window. Wow. Okay, a couple of more word problems here. And they're not too difficult as long as you understand these two basic formulas. If they say it's direct variation, then it's this. If it's inverse variation, then it's this. So for number 19, they're saying the time required to do a job varies inversely with the number of people working. So there's your basic formula. Time equals K over P. It says it takes 4 hours for 9 people to do the job. So what is your constant of variation? Well, you, in a sense, just cross multiply K equals 36. So there's your basic formula. Well, how long would it take 10 people to do the job? And there's the 10, and it's going to be 3.6 hours. For number 22, they say the current I, which is measured in amperes, in electrical conductor varies inversely to the resistance, which is measured in ohms. I don't know how electrically inclined you are. So it says, if the current is 2/5 of an ampere, that's what you put there, then you need your constant of variation, and your ohms, which is resistance, is 120. So again, you would cross multiply 5K equals 240, divide by 5, K equals 48. And then they said, what would the amperes be if your ohms, the resistance, was 150? So you replace the R with 150, and you just do your canceling out as best you can. And I believe 6 will go into there 8 times, and 6 goes into there 25 times. So again, you have some word problems. And now we're going to go into joint and combine variations. Now as we continue, we're getting what are called combination of variations and joint variations. And again, as you read what they give you, they're going to tell you whether something is direct variation, inverse variation, or a combination. You follow along with what is said. So for instance, in number 23, they're saying y varies directly as the square of x. So there's your basic formula. And then y is 90, x is 6. And where students often make an error, they'll think that 6 is x squared. No, you have to square the 6. So that becomes 36. Divide both sides then by 36, and that gives you 2.5. So K is 2.5. So your equation of direct variation in this case will be y equals 5/2 x squared. I would have accepted the decimal form, but they're looking in the booklet for the fraction. These are equivalent. Number 24. X varies inversely. So inversely is going to be k on the numerator spot, and then it says the square of x. So inversely to the square of x, in the denominator, x is squared. And they're saying that we have 72 for y, and x is 0.5. Now remember, you have to take that 0.5 and square it. So this will give you 0.25. And then you're going to multiply both sides by 0.25, and you get k equals 18. So what would the formula be here? Well, the formula is going to be y equals k now. We know that is 18 over x squared. Remember, this is an important part of the answer. For number 25, it says y varies jointly as x and z. So y varies jointly, x and z. And again, you need the k. And inversely as w. So anything inversely goes in the denominator. Then it's a matter of filling in. They're going to give you all these values. So this is 30, this is 10. 30 divided by 10 is 3. Divide both sides by 3, we get k is 3. So 9 divided by 3 is 3. So what will your formula be? Well, it's going to be y equals, k we know now is 3, xz over w. Now if I were going to write these as I was going on, it would be tedious. This makes it quicker, and hopefully you can follow. Remember, you can always go back and look at these examples again. All right, number 26. It says y varies directly as the square of x, and inversely as w and z. Then they're going to give you, for y, 16, for x, a 10. Remember, you need to square the 10. W is 25, and z is 2. Well, can you see that this becomes then k 100 over 50, which will become 2. You divide both sides by 2, you get k is x. Let me say that again. K is 8. So over here, all we do is we put an 8 in there, and then there's your answer. And that's how you got it. So again, slowly reading the problem, carefully substituting values, and you know, the work is not that difficult, but you need to know the rules. The key is, if it's direct, y equals kx, inverse, y equals k over x. And then follow through. Okay, to wind this up, we'll do number 29. And again, they have a little chart. Talks about the number of artists and the number of figures that can be produced. And they're wondering, as you look at this data, what kind of data does it look like? Does it look like direct variation or inverse variation? Now, an interesting thing occurs when we look at this formula, by the way, over here for inverse. If you multiply both sides by x, you get xy equals k. So the product of every multiplication of x and y values is k. And you notice in the chart, as you multiply each one of these sets of data, it ends up being 2400. So if you substitute any value in there, you're going to get that k is 2400. So there's your formula. And of course, this is an inverse relationship. And if they have 16 artists, how many figures? Well, you just put down 16 as the denominator, do the division, and you end up with 150. So again, we wish you good luck on this. We're going to be going on to chapter 7, which is radicals. All right.